Assalamu alaikum. Welcome to the third lecture of natural language processing. I hope all of you are doing well. The COVID virus is spreading again quite rapidly, and I hope all of you are taking precautions for yourselves as well as for those around you. So today we will continue with our discussion on regular expressions. We will quickly go over a common syntax that is used for regular expressions. After that, we will then talk about text preprocessing, some key steps that we can do during text preprocessing. During this part, we'll also talk about words in general and linguistic units in particular. And if we have time, we will then move into tokenization, including subword tokenization. So that is basically the agenda for today. So this is the second week of the course. So we should also now start planning for our instruments, graded instruments. So I was thinking of taking a quiz maybe next class, but maybe I can take it next week. So we will start with maybe next week as with the first quiz, and then thereafter we'll probably have a few quizzes every Tuesday. So, and you will also probably get your assignment very soon, first assignment. And I will also upload a file on LMS. I've not done that yet. So that file has some links to some related material on the web that we are covering in class. So that is for your supplementary reading. So you will have some links on, let's say, tokenization, for example, or text processing, and later on we'll talk about language modeling and so on. So some useful reading, you can say, to supplement your understanding of the content. Of course, you know your textbook. The textbook Speech and Language Processing is available on the web. And of course, we are now discussing chapter 2 of that textbook. So any questions?
Sir, can we have quiz on Thursday instead of Tuesday?
Could you speak up a little bit? I didn't understand.
Can we have our quizzes on Thursday instead of Tuesday?
I don't have any problem if that is okay with everyone. So every Thursday, so should we start this week?
Yeah, sure.
So anyone else wants to comment on this?
So maybe we can have it next week so we can have the weekend for preparation.
Next week? Okay. Okay, so we'll then be starting our first quiz a bit late, I think in the third week. So, okay. And also the second thing is the content भी ज़्यादा cover हुआ होगा वो फिर आपको obviously prepare करना पड़ेगा. So, so you are saying that we should have quiz every Thursday and we should start the first quiz next week. Is that what you are saying?
Yes, sir.
अच्छा, ठीक है. ठीक है. चलें ठीक है फिर I think that's fine, but then we will have to push our quizzes. Remember, if you have around 8 quizzes, I will drop one. If you have less than 8 quizzes, then we won't be dropping any quizzes. All right. So we were discussing regular expression last time. Regular expression, also called regex for short, is basically a language, a formal language that specifies a set of strings. So in other words, it's meant to find strings that is specified by the regex. So regex is a way of specifying some strings, and then you can, once you have specified those strings, the algorithm, for example, can go ahead and find that particular string or set of strings from your text. Actually, today I'm also a bit under the weather. I don't know, just a bit of sore throat and a running nose, but no fever. So I don't know what it is right now. You can just give me a second. All right. All right. So there are two standards that are commonly used for specifying regular expression. I just mentioned those. POSIX, this is more common in the Unix environment, Linux environment. And the other, which is uh, more widely available, often called a de facto standard, is the Perl standard. Perl is a scripting language, and the Perl standard uh, is often implemented, of course, in Perl as well as in other languages. So you will find regex implemented in many languages, as well as you will have libraries available for them. So we will be following the syntax that is given in the book, so that everyone knows exactly what we are doing. And then, of course, if you're implementing using some specific language, you can look at the help, and it's not very different across these two standards, but still you will have to look at a specific implementation to make sure that you are doing it properly. All right. Okay, so I'll quickly go over the syntax, and I think I won't spend too much time here because most of this is easy stuff. So the first, of course, there are two types of characters that are specified in the language. One is a literal character, which basically means that whatever the character is, that's what you're trying to find. And the other is meta character, meaning that the literal meaning is not meant, but there is some other meaning that is meant, a special meaning that is meant for the character. So for example, if you write A and B, and by the way, another notation, delimiters are often used to identify where a regex starts and where it ends. So slash and slash, between these two slashes, you have the regular expression. And these delimiters are used in the book. And of course, in some other implementation, you might have other delimiters. So the AB string would match only the character A and B in order and in the same case, lowercase. So this is A here is a literal character, it matches itself. B also is a literal character. And of course, this sequence AB would match exactly with the sequence AB in some data. So similarly, I can write some person's name. Let's say you are trying to find someone's name. Let me write my name. So this will match exactly with my name, starting with a capital A, small s, and I and M. And if it occurs multiple times in running text, it will output all. Of course, this is also somewhat different with different implementations. In some implementations, it outputs all matches. In other implementations, by default, it outputs the first match. As you know, for example, if you're doing searches in Google, in Microsoft Word, it will output or search the first match, and then you have to click another button to find the next match and next match and next match and so on. So, so it depends on the implementation in code. It might give you the entire set in one go, or it might give you the first match in the first step, and then you need to do something else to find the next match. Okay, so that is the literal. Now let's move on to some meta characters. So the left bracket and the right bracket are used to uh, enclose characters, literal characters that are then odd or disjunction. So this is meant for disjunction. So for example, if I have AB, so this will match A, the character A, or it will also match the character B. This is not the whole sequence AB. So for example, this would match, so A name. So this would match the first A, this A, and this A, but it will not match. Of course, there's no B there. So A, it will match A, and it will also match B if it is available. Of course, in this sequence, it's not available. Okay. So this is disjunction. So you can, within disjunction, you can also use negation. So for example, of course, this symbol caret, sometimes in some implementation, some other symbol is used, AB. So now caret here again is a meta character. Bracket, of course, is a meta character. This caret is also a meta character. And this only applies to the character that occurs immediately after it, A. So this essentially means that not A or B. So for example, the same example I mentioned earlier, A name, if I have this running text and apply this regex on it, so it will output every character which is not A, which by the way also includes B. So and or it uh, outputs B. So in this case, it will output the set. Of course, you have the space also. So N and M and E. So this would be the output string for this regex. The caret has the meaning of negation in brackets only if it is the first character. If you use it as any other character, for example, caret B, so this would match literally. Here it will have a literal meaning. So this will only match, this would mean A or the caret or B. So there are three ors there, of course, character level. So caret here does not mean not B. It is actually the literal meaning caret. So, so this was disjunction for characters. So you have to enclose them in square brackets. And if there's a caret at the start, so the next character would be negation, negated. So there is another symbol for disjunction, and this is more useful if you are disjuncting over multi-character sequences or strings. So that is the pipe symbol or the vertical bar or the pipe symbol. So for example, if you want to find two names, let's say Asim and Asif, so you can write it in this way. So it will either match Asim or the whole sequence Asif. And of course, pipe symbol can have multiple names. So Asim, Asif, and for example, Atif and Amir, for example. All of these are odd. So the pipe symbol here again is a meta character. It is not taken literally. It has a special meaning. So whenever you want to, let's say, find a character which is a special character or meta character, literally you'll have to escape it. And the escape sequence usually the backslash pipe. So if you have something A, B, of course, I was not writing the delimiters before. So this is the regular expression. So this would exactly match A vertical bar B. So here the backslash is escaped and it then means the literal vertical bar. So the backslash escapes the vertical bar and the meta or the special meaning of the vertical bar is reduced to the literal meaning. So let's move on to some other symbols, which are generally, you can say, counters or quantifiers, where you are trying to match, you're trying to control the count of the matches. So in this case, we have, for example, the symbol, again, this is a meta character, the question mark. So the question mark basically means 0 or you can say 0 or ones. So just to give you an example, for example, you can have the color. So what does this mean? So this is actually equivalent to color. So in other words, the U, which is the literal character preceding the question mark, which is a meta character, is optional. Either it occurs or it does not occur. So that is the meaning of the question mark. The character that precedes it is optional, 0 or ones. So as I've written here, you can write regular expression. There might be multiple ways of specifying a set of strings. In other words, if you want to find a set of strings, you can write regular expression in different way. There might be multiple ways of writing it. So in this particular case, if you are looking for color with OR and color with OUR, you can use the question mark symbol, or you can write it with two words with the pipe symbol between it. It will return the same answer. So that is the question mark. Then we have the asterisk, which means 0 or more. So asterisk 0 or more. So you have either no characters or maybe more characters and no limit on the no upper limit. So for example, A, and then I have asterisk, and then I have H. So again, asterisk here is a meta character, quantifier, a counter character. So this would match, for example, AH, uh, 0, 0 or more. Yeah, so it will also match. Let me just change it. Let me write two A's there. So it will match AH. It will, of course, also match AAH. It will also match AAAAAAH. Any number of A's after the first A. So the first A, of course, literal. The second A has a asterisk after it, which means that it is 0 or more times. So it will match with all of these options in all of these strings. And then finally, among the of course, there are more as well. One more is the plus. which means one or more. So the same, I could have written the same regular expression as before using A plus H, which is almost identical to A asterisk H. So both of these are identical regular expressions. So what is plus? Meaning that the previous character must occur once, or it can also occur more than once. So it will also match AH, and of course it will match all of these as well. All right. Some implementations also give you greater flexibility on the number of matches, and the syntax for that is, let's say, so A 3 H. So the brace and some number inside it, and then the right brace. So this operates on the character before it, and it says that it must occur exactly 3 times, or n number of times, whatever that is number inside the braces. So this would match so H and nothing else. It will not match AH or any number of A's with H. And then, of course, there are some other variations. The one that we mentioned is basically N. So other variations are, you can also specify a min and max, M and N. So M is the minimum number of times that it should occur. N is the maximum number of times that it can occur. So all of those options are possible. So for example, A, let's say 2 and 4. So this would match with at least 2 values of A. It will also match with 3 values of A, and it also match with 4 values of A, minimum 2, maximum 4. And of course, then after that, it should have an H. You can omit one of these two numbers. So for example, nothing here, and then let's say N. So in this case, you have, there is no minimum, but maximum should be N. And similarly, you can omit the second one, M. So this means that there should be at least M characters preceding this and this special set of symbols. And the maximum, there is no maximum. It could be as many as possible. All right. Okay. Okay, one more symbol is the period. This is again a meta character. So this matches any character. So there could be any character at its position. So for example, if I have let's see. So anyway, you can just think of some example. So I'm just trying to think of an interesting example, but anyway, so let's say I have color dot R. So this period would match with any character. So in other words, you can have COLOUR. This is also possible, but in other words are also possible. Let's say KR, COLO, even space would also be matched, space R, and so on. So one thing to remember about this dot operator is that this dot operator is a literal, it has a literal meaning without being escaped when it is part of a disjunction in square brackets. So for example, A dot B, this would exactly match A dot B. Sorry, it will match either A or dot or B. So within a disjunction, it does not mean the special meaning of any character. Elsewhere, it means any character, and if you want to it be the special character, for example, COLO, and let's say you do want to match the period here, then you will have to escape it. Oops. Okay. So here it will match the dot. So we have escaped the special meaning of the period, and it will actually match the dot. So which means that it will match with CO dot R. All right. So any questions so far? Any questions so far? Of course, all of this you will get better practice if you do practice using language as well as on paper. You will get an assignment on this as well. किसी का question था? All right. So a bit of grouping, for example. So you can use parentheses to group sequence of characters so that they appear at one as a group and not a single character. And for example, let's say if you want A, B, so the counter brace 3 would operate on not just B, but the entire previous sequence, which is AB. So in other words, this will match AB, AB, AB as a whole. Okay? So the grouping can be done using parentheses. And parentheses also another important point regarding parentheses is whenever you have such parentheses in a regex, this has the highest precedence. Just like in math, whenever you see parentheses, you first look at the parentheses and do that and then go to the next step. So parenthesis has the highest precedence of operation, and then you move on to other, and basically the disjunction pipe symbol would have a lower precedence and so on. And I think pipe symbol probably has the lowest precedence. There are some other advanced things that are possible in regex, and it depends on the implementation. I won't go into those here. You can use, for example, substitutions, for example, or capture groups and other things. Also, you can use them programmatically in as a variable in your program. So these things you can look into while you are actually implementing using a particular implementation of regex. But the what I mentioned so far is the core of regex, and it can be used to define a set of strings, and those set of strings may have various applications. For example, they could be for spell correction, they could be for, let's say, normalization, which we are going to talk about shortly, meaning that you want to find variations of a word. It might be used for finding specific strings like dates or currencies, uh, and so on. And for more sophisticated things, you can also use regex as a variable in a machine learning problem. So for example, you can define, so let's say the example that we talked about, COLOU question mark R. So of course, this regex matches color, which is the English, sorry, which is the US spelling, and color with the U, which is the British spelling. So you can use regex as a variable name, and let's say you have a binary variable. So whenever that variable is found, you will have a value assigned of 1 to it. So now 1 would be assigned not just to the OR form of color, but also whenever you find the OUR form of the color. So you, in other words, you get better generalization, and you are able to capture writings of, in this particular case, British and US writing. But in other words, you can capture generalizations, variations, and have just one variable for that. Because semantically, both of these are the same thing. Okay, any questions? All right. So now let me move on to basic text processing or preprocessing. Here, as we mentioned before, text is a sequence of characters. And whenever we want to do some analysis on text, we will have to appropriately represent that text. And usually we take subsequences, appropriate subsequences of text as some representation unit. So we usually call those as linguistic units. And in the book, it's also mentioned that you can call these as types. So, for example, you can have characters, chars, as types or linguistic units. So let's say if you have defined a set of characters, then you can represent any sequence as a sequence of those characters. For example, so he lives in Lahore is the sequence capital H, E, then you have a space, and then L, I, V, E, S, space, in, then capital L, A, H, O, R, and E. So each character is represented separately in computation. It is represented separately in the computer. So in this case, we have each of these characters as a linguistic unit. How many distinct linguistic units would we have if we assume we are only considering the English language and also assuming that we don't have punctuations? So in the English language, of course, you have 26 characters. So of course, if you are considering lowercase and uppercase, then you will have 52 characters. So this is the set of types that you have, or linguistic units that you have. So this is what is meant by type. But whenever a particular type occurs in running text, we call that a token. So for example, in the previous example, so H is a token, E is a token, L is a token, I is a token, V is a token, and then E again is a token. So there are now two E's and all of them are tokens. But if you think of type, E type, and it's just one type or one linguistic unit. So in other words, the set of tokens is the types. So we also call this basically the set of tokens or the all possible types as the vocabulary of our analysis. So distinct tokens form the vocabulary. So we also denote vocabulary by V. So the size of the vocabulary, the usual notation is if V is a set and you use the vertical bars to denote the size of the set. So this is the size of the vocabulary. And N is the number of tokens in running text. So in the example again that I gave before, he lives in Lahore. So the number of tokens, if we are considering characters as our type, is actually the length of this string. So we have H, which is 1, E, 2, we have a space 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So number of tokens is equal to 18. So if we restrict ourselves to just this sequence, so what is V then? V, of course, is H, the capital H. We have E, we have the space, we have L, we have I, we have V, we have S, we have I पहले हो गया N, and we have capital L, we have A, we have H, we have O, and we have I. So this is the vocabulary. And of course, here we are considering individual characters as our type. So what is the size here? 3, 4, 5, 6, 7, 8, 9. Okay, this is capital L. 10, 11, 12, 13. I think it's 13 if I'm correct. So basically, so all right. So this is what is meant by vocabulary, type, and tokens. So tokens are any occurrence of a vocabulary in running text, while vocabulary is the set of linguistic units of interest in our analysis. And the example that I've done so far, we have considered the vocabulary to be single characters, vocabulary to comprise of single characters only. But as you can imagine, maybe single characters may not be good representations because single characters contain very little information. So in practice, we usually look at larger units, linguistic units. And one common larger unit is a word. So we would like to consider a type or a linguistic unit to be a word in that language. So if I do that, then again, going back to my previous sentence, he lives in Lahore. So how do you define a word given this running text? So that is one that question that you will have to ask and answer while doing text preprocessing. Of course, everyone knows what a word is, but once you have a running text, you will somehow need to computationally extract words from that running text. So one very simple and common way of doing it is basically space delimiting. And of course, if starting and ending of sentence is also part of it, space delimiting. So if you do this, then how many tokens do we have? We have HE as a token. We have LIVES as a token. And then we have in as a token, and we have Lahore as a token. Okay? So we have 4 tokens. And if we take our types from these tokens also, so in other words, N is 4. If we consider these to be, we take words and we restrict our words to these 4 words, then the types also, vocabulary also consists of these 4 words. So obviously, there is no repetition of tokens in this running text. So vocabulary is essentially the same, but now our linguistic unit is a word. But if you have some other sequence of words, so he lives in, for example, Lahore. So now you notice that we have 2 occurrences of in. So those 2 occurrences would be part of the tokens, but the vocabulary set would just have 1 in it. Because as I said, vocabulary by definition is a set. A set, as you know, cannot have repeated items or elements. So going back to our notion of a word, so we have defined words as space delimited, but that is kind of complicated. You might have punctuations as well. So someone can write he apostrophe S, which is a contraction for he is. So what do you do if you have parentheses? What do you do if you have punctuations? So there is actually no one answer to this, and sometimes dependent on your application. So one common way is that you remove all punctuations and add a space there. So he space S. So now HE would become a token, S would also become a token. Of course, the token S doesn't have much of a meaning. It's just a single character. But such errors can occur, and we should be able to kind of understand the pros and cons of such errors in our final analysis. Okay, so we have talked about character as a type. We have talked about word as a type. So finding characters in running text is very easy. Words, you would have to find them most likely using space delimitation, and which also would also give you some errors. But if you have punctuations as well, you will have to adopt some other techniques. Sometimes one way is you remove the punctuation and add a space there, and then do space delimited tokenization afterwards. Sometimes people also do this, so for example, you remove the punctuation, but do not add a space. So in other words, it will become his. Now, HES would then become a token. So for example, DON-T, this would become don't, rather than DON and T. So there are also other issues. For example, people sometimes, for example, we write DR dot. Of course, this won't cause a problem. So for example, Dr. Asim. So if you remove punctuation and add a space there, this period would be removed, and you will have DR as a token and ASIM as a token as well. And this would be the same. Let's say if you remove the period and add a space there, again, you'll get DR as a token and ASIM as a token. So in both cases, you'll get the same two tokens. But this is not always the case. Okay. So there is an intermediate way of tokenizing as well, which is sometimes a bit more, you can say, intelligent, because this is more recent and people have developed more sophisticated techniques for that, which is called subword tokenization. So we talked about character tokenization, talked about word tokenization, now this is subword. So as the name suggests, this is something between word and a character. So subword tokenization, this is a more recent phenomena and more commonly used also for preprocessing before applying any neural network algorithm to text. And there are a number of techniques available out there. For example, byte pair encoding. So we'll discuss this briefly, byte pair encoding, but there are other techniques also there. For example, word piece, which is similar to byte pair encoding, but I'll mention what is the difference shortly. So this is word piece. And then we have also unigram-based tokenization. I think it has a name called CUDA or CUDO. So it's a fancy name. I don't remember exactly. And then there is also more recent ones as well. For example, a new neural network that was released recently uses a slightly different tokenization. Of course, there's another one called, I think sentence piece is a library. So sentence piece is a common library that's available for tokenization that implements one or two or three of these tokenization techniques, BPE or word piece, for example. So what is the idea? Let me discuss BPE briefly, and then I'll mention the slight difference between BPE and word piece and other variations. So BPE. And what is the motivation? Okay, we'll discuss motivation also afterwards. Become easier afterwards. So as we saw, when we took characters, uh, we were able to get a smaller vocabulary. But when we go to words, we will get a very large vocabulary. Why? Because, for example, we saw LIVE, this would become a type. LIVES would also become a type. LIVER would also become a type. So the total number of types or the vocabulary set size would become very large for normal corpora. On the other hand, if you limit it to just characters, then as I said before, if you're just considering upper and lower case, you'll just have 52. If you add punctuation, maybe you go up to max 100 or so on for the English language. ASCII characters, I think they are 128. So you shouldn't go beyond 128 for English. But if you think of words, then you can get a lot of words, distinct words. And I think there's a nice slide there. Let me show you that distinction between. Okay. Which page is it? Okay, this is the one. So these are some common corpora that are available. Of course, there are many more corporas available nowadays. So these are some typical examples. So switchboard phone conversations, this is a call center data set. So call center, people call and ask questions and they respond and so on. So the number of tokens in this data set is 2.4 millions. So this is the number of words, total number of words, irrespective of repetition in the data set. But the number of distinct words or types is only 20,000. So you have 20,000 distinct words used in the switch board data set. So if you talk about writings of Shakespeare, so you have over 800,000 tokens. So these are total number of words that Shakespeare has written. So the number of distinct words that he has used is 31,000. So if you go to the Google Ngram dataset, this is a huge dataset prepared by Google from the web mostly, and of course books. So you have 13 million distinct words. So you can think of words from different languages, spelling errors, and so on. The number of tokens is massive, 1 trillion. So the corpus size is determined by the number of tokens, the variety of, you can say, words or types that are in that particular data set is determined by the vocabulary size. All right. So it happens that much of English and many other languages can be broken down into subwords, and those subwords can then be combined to form different words. So for example, if you have the word LOWER, you can have a subword LO and you have subword ER. And they can then be combined to give you lower, for example. And ER subword can also be combined with, for example, L, uh, for example, uh, let me just think of some other. So for example, high and ER would give you higher, for example. So the number of, if you use subwords, then the number of distinct words would become smaller as compared to if you use words. But you will still be able to construct distinct words uh, by combining such subwords. So this is also a way of avoiding what is known as the out of vocabulary problem, OOV problem. So what does this mean? For example, in your training set or in your corpus that you're analyzing, you did not find maybe a particular word, but that word is available in the test set. So I can take the example of, let's say, LOW. Let's say only LOW was in the, or LEWER is not available in the training set. So if you use word tokenization, this lower would not be part of your vocabulary. But when you go to the training side, you will find lower there. So this is an out of vocabulary problem. But if you had done subword tokenization, your type would be low and ER. And whenever you go to the test set, even though lower was not available as a whole word in the training set, in the test set, you would still be able to understand LOER because you have ER separately and LOW separately, and you can combine them to get the word LOER. So subword tokenization, the number of distinct words, the number of distinct types in the vocabulary is between characters and words. Uh, that's one thing. The second thing is it can handle the out of vocabulary problem much better than words. And it is better than, for example, characters in the sense that it captures greater meaning. So LOW is a subword which is capturing a meaning rather than single characters L, O, and W. So this is an intermediate way of tokenization. So let's go back to BPE. So what does BPE do is very simple algorithm. So first of all, you have to find the set of types or set of units in the vocabulary. So if you talk about, let's say you have some corpus, which of course is the training corpus, let's say. So any running text, let's say a book or a web page and so on. So you start with single characters as vocab. So start with single characters. Then you find the pair of units from vocab that is most frequent in corpus. Most frequent. So this is a greedy approach. And then once you have found that, and assuming, and if there are ties, you have to select one. Then you add it. Okay? And essentially you repeat. Where K is a parameter. So again, to repeat what happens, let's say if you're talking about uh, uh, let's see, let me think of some example here. Okay, let me just take some words here. LOW, LOWER, and let's say all right. So let's say this is my corpus, 4 words. So at the start, my vocab would be, this is a set. So LOWER, F, E is already there, and W is already there, and that's it. So this is my vocab at the start. So now from this vocab, I find 2 pairs, 2 units, and count them in my corpus and see which one is occurring most frequently. So for example, if I talk about LO occurs twice, FE also occurs twice, okay? ER occurs also twice, right? Fewer. So ER also occurred twice. Are there any 2 characters that occur 3 times in this data set? W. WER.
WE.
WE. Yeah, you're right. Oh, no. This is 2. No. WE भी 2 दफा ही आ रहा है. 3 दफा तो नहीं आ रहा. EWB 2 दफा आ रहा है. So all of them are 2. So whenever you have a tie, you have to just select one. Of course, this might cause problems in this small example, but of course, usually you will have a huge corpus or ties के chance होते हैं. But so all right. So I would say that let me take ER. Okay. Of course, there are many other words that 2 words are from this vocabulary that occur twice. And once I've selected this, I will add it to the vocab. So V now becomes LOW, and then add ER there. All right. So now we have our vocabulary size increased by 1. I now repeat this and now find, now ER is considered as a whole now. So as a unit now. So my original corpus would now not have E separately and R separately, it will be ER as a unit. So if I write the original corpus, LOW, by the way, LOW would be LOW, then LOW, ER would be together, FEW, FEWER. So now you find now pairs again, which pair occurs most frequently. So you find LO is 2, WER is also 2. So again, you have a tie actually. Any other 3 का तो मेरे ख्याल से probably नहीं होगा. So so let's take LO. So LO के लेते हैं हम, ठीक है? You add this to the vocabulary. So we have now ER, we have LO. So now you again go to your corpus and now combine LO, LOW, then LOWER, and then FEW, FEWER. Again, now try to find pairs that the pair that is most frequent. So इसमें कौन सा होगा, LOW जो होगा वो भी 2 दफा आ रहा है. Again ties काफी हैं इस एग्जांपल में. So anyway, I think you get the idea. So अब let's say if you choose LOW, ठीक है, तो now your corpus would be ER LO and then क्या था LOW. So you continue this until you have K additional vocab items added, and K, as I said, is a parameter. So now you have a vocabulary that consists of single characters and bigger characters, bigger sequence of characters. Once you have this vocabulary, how do you actually do tokenization? So the tokenization is done, let's say you have a new corpus, let's say, let's say we have FEVER, fever. So you basically have to look at your vocabulary from, so if you look at the vocabulary, so we added ER first, then LO, and then LOW, right? So it proceeds in the same fashion. So first you tokenize. So actually I'm using two, you have to start from one. First you tokenize using the single characters, meaning you start from left to right in the vocabulary list, meaning that vocabulary list is ordered according to how you add new vocab items into it. You tokenize them. So you then start from the first character, you tokenize it, second, third, fourth, and then repeat with bigger vocab items in it. And you stop when you cannot do any further merging or item units in it. So the final units that you get in the new text would be your tokenization of that character. For in this particular case, I think you'll probably get FE वैसे बन जाना था पहले भी, उसमें FE हमने किया नहीं. So FE separate होगा, V हमारे पास था ही नहीं actually. In this case, you get an out of vocabulary error. Very small problem with you. ER इकट्ठा होगा. So again, those phases. The first phase is the training using a corpus, which is a corpus of the language that you want to tokenize. You build a vocabulary using this iterative approach, starting with single characters and then merging combining based on the most frequent two items from the vocabulary. Okay? And you stop after K iteration. Once you have this vocabulary, you use this vocabulary on any new data set to tokenize it. And you do this from left to right in the order in which you added those items or units into the vocabulary set. Once you have done this past the complete vocabulary list, and you are not able to merge or find any more tokens, and then you are done. So this approach is the subword tokenization by BPE, or byte pair encoding. So as I said, there are other, we are also running out of time. As I said, we have other variations as well. So word piece, for example, is very similar, only that instead of taking the most frequent pair in each iteration, it actually does language modeling using the existing vocabulary. And language modeling we have not studied yet. That's why it will be difficult to understand here. So in other words, you would say, instead of just taking the most frequent word, it has a probabilistic model of the language using that vocabulary, and from those probabilities that you get the next, add the next word into the vocabulary, add the next pair into the vocabulary. Okay, so it involves probabilities rather than just a greedy first. Actually, वो भी greedy ही है, but it involves probabilities and language modeling. And of course, there are other variations as well. So you can read more about BPE word piece on the web, as well as BPE is discussed also in the book, chapter 2. And so in the next lecture, we will be wrapping up with text pre-processing stuff, and maybe start with the minimum added distance, which is also part of chapter 2, by the way, and in the next lecture. So what have we decided regarding quiz? Are we having quiz on Thursday or the following Thursday? अच्छा, ठीक है, चलें, ठीक है. I think I will agree to your suggestion next Thursday, but ठीक है, पर ये कि आप फिर ये रखें कि उसके बाद इंशाल्लाह एवरी थर्सडे को फिर होगा. सो यू हैव टू बी अप टू द टास्क. 2 हफ्ते आपके पास रिलैक्सेशन मिल गई आपको. You will get the first assignment by the end of this week, maybe early next week. वो आपको मिल जाएगी. But as you have said, quiz आप लेट करना चाह रहे हैं, तो that is fine with me. But then you need to make sure that you are ready for the quiz every Thursday. ठीक है? Any question?